Great, thanks, Ted. So thank you everyone for joining us this morning or afternoon or evening, whatever time it is where you are. So this is our week 2, day 2 session for the Maps for the Web workshop. My name is Ryan Ahola. I'm a member of Natural Resources Canada, and I'm part of the program committee that's been helping with organizing this workshop. So today we have a few different sessions, starting with first presentation about creating accessible web map widgets. And then we'll have a panel discussion about the same topic. Then we'll move into presentations on 3D map display, and also looking at, followed up by a panel session on maps and augmented reality. And then we'll close with a breakout session of GeoPose with maps of objects with GeoPose for web maps. I think Peter posted the link to the Gitter chat in the chat for Zoom. So if you can access that, and if you have any questions or any discussion, of course, use our running Gitter chat online. And I think that's all of the logistical information today. So I guess we'll start with the presentation from Nicolò. Oh, I'm going to mess up your last name, I'm sorry, but Carpignoli and Joshua O'Connor about accessible web map widgets, specifically completed an introduction from the research questions accessibility task force of the Accessible Platform Architecture Working Group. And I believe this is being done through a video, which I've set up here. So I'll make sure that I'll share my screen and we'll make sure that we're looking at the right one. Okay, excellent. Of course, it doesn't work when you want it to work. There we go.
Hi, everybody. My name is Nicolò, and today I'm going to talk about accessible annotations for a native map viewer for the web platform. I'm going to show you user needs and requirements. I'm from the W3C APA. I'm an invited expert. And first of all, I'd like to thank Joshua O'Connor from the W3C that has helped me a lot with this presentation, and all the other members of the RQTF from the APA W3C. So today we're going to talk about accessibility and maps. As you know, maps are used every day to find routes, to navigate, provide other information, and all other very important user needs. Maps can be either complex or simple objects. And according to the user needs, they are configurable. So user, most of the time, switch between different layers in order to see different data for the same geographic area. So, as you can imagine, in general, maps are a complex object. And from an accessibility perspective, they represent a challenge. But we have to start from one aspect, and maybe the most important is the need for annotations. We talk about annotations of geolocated data and maps metadata. Why are they so important for accessibility? Because once those annotations are specified and then delivered, they become available to be read from machines or from humans from different outputs, such as non-visual outputs like speech synthesis or like symbols. And this is very important because text annotations is the most portable format and the only one that can be translated into other formats. So we start from the text annotations and then we can deliver data and the information for different user needs. We have grouped all these use cases and requirements into 4 main fields regarding use cases for maps: information retrieval, navigation, comparing, and monitoring. And we are going to start from the first one. But first of all, we like to state that the following user needs are neither exhaustive nor definitive. They represent a starting point to begin to orientate towards user needs and potential requirements. So it's a kind of a way to start to think about accessibility for a map object for the web. So, user needs for information retrieval. We are going to start from the first user needs and the first two requirements. Okay, so the first user need, a student wants to learn the boundaries of a certain geographical area. We have two requirements to solve this. Different regions must be labeled with text and other metadata, and each place of interest, for example, like cities, should be available with labels that should contain not only the place of interest, but also the region where it belongs. In this user need and all other presented in this presentation, metadata may be area or other HTML attributes. So this is to give some kind of nomenclature for metadata. The second user need, a researcher wants to analyze a geographical area using different zoom levers and measurements. So users should be able to configure their experience on reading the map. This is very important because different users might need different scale, unit, and other metadata in order to read and to understand the data that are on the map. And so scale, unit, and other metadata should be available as labels on the map context. Of course, they also must be editable using available controls on the map. User need 1.3. A user wants to study only the rivers and the lakes of an area without being distracted by other data. This is very important because, as we said before, data are very complex objects, and so most of the times users just want to read only certain data rather than all the data that are available on the maps. And so, as a requirement for this user need, mass different data must be available as layers that can be switched on and off by the users according to their user need. And the active layers must be available as text labels, so they are they can be found easily by users while looking into the map. Now we are going to talk about user needs for navigation. We start with this user need. A user with low vision wants to highlight the route between two places. We have one requirement that might need to be solved in order to solve this particular user need. The distance between places must be available as a text label. This is very important because when a user wants to navigate towards a specific destination, one of the most important information that he or her needs is the distance. And so if the user is using a real-time navigation mode, that is very common. So think about we are a user that wants to navigate towards a navigation, and we are moving while looking into the map. And so we are using real-time or near real-time navigation mode. In this case, the distance should be updated because the position of the user is updating, and this update should be presented to the user with text labels and should contain information about its new position. Another user need about maps and navigation. A user who finds orientation difficult wants to navigate towards a destination. This is a very common user need. If a real-time navigation mode is enabled, as we said on the user need before, the direction to follow must be available as text labels, and every update or change must be presented to the user. But as we know, not every user finds himself comfortable on using navigation, orientation while looking into the map and while walking, for example, on the real world. Sometimes this might be distracting or not easy to understand. And so, most of the time, if a real-time navigation mode is enabled, the user needs direction that should be available as visual hints, like arrows. So not only like as text labels, as text information. Of course, if the user is using visual hints, it should be presented also proper alternative text. So alternative text with visual hints and also text labels for in order to navigate towards a destination is very important to be provided. In this case, if using visual hints, the alternative text will need to be dynamically driven and accurate and also updated in near real time. This is very important because not every user finds himself comfortable in using text navigation information. Another important user need about navigation can be this one. A wheelchair user wants to know the estimated time needed to move toward a certain destination following a route on the map. The estimated travel time is, as we said, for the distance and other important information while using maps for navigation. And the important thing here is that estimated travel time is strictly bounded to the travel mode. And so estimated travel time must be available as text labels, and also the estimated travel time must be available for different travel modes. This is important, as for example Google Maps does, to present different travel modes with different estimated travel times. And the important thing here is also to present to the user only those travel modes that are concretely available, really available on that path for that destination. So if the map presents estimated travel time according to travel modes that are really available for that path, the user has all the information that he needs in order to know how to navigate toward that destination using the map. This is a very common user need for maps. So now we are going to talk about user needs for comparing. A journalist wants to study data about the spread of a virus on a large geographic area. He wants to quickly understand the relevant data and spot the differences between the countries. Also, this one is very common because think about maps using on magazines, on newspapers. These maps should be easily understandable for a very large number of users. And so numeric data should be available as text labels placed over the map and not only just with visual highlighting. This is important because and a very important rule for accessibility in general is not to rely on colors, not to rely on only on symbols, on shapes, on sizes, because users may not be able to spot differences on colors and on sizes easily, for example. And each label should contain the value, the unit, and the related countries. So all the data that the user needs to understand in order to understand the big picture. Another requirement, if numeric data are shown, as we said before, using colors or symbols, a legend must be available as text annotation on the map context or near the map context. And this is important because if we are using not text data, so visual highlighting of some kind, we have to provide a legend in order to understand those symbolism, those coloring, and etc. Another example, strictly related to the prior one, A blind student wants to know the demographic data of a certain area specified on the map. In this case, we are also talking about numeric data, but we are talking about of a blind student, a blind user. And think about this blind user that wants to navigate all those data over the map that are, yes, are shown with text labels, but they are a lot. They are a very large number of information on the map. And so the user should navigate one by one, and this is very difficult. It will become a very bad experience, a very bad user experience. And so in these particular cases, when we have a large number of information as numeric data on the map, it should be provided an alternative mode in order to read those data. And with alternative mode here, we have an example. Numerical data on maps are usually shown with different colors, graduation of symbols, for example, for different sizes. Think about a city with 1,000 people that is highlighted with a big red circle, and instead think about another one with 10 people that is shown with a tiny dot. Not every user may prefer or may be able to spot differences. And so people who find difficult to differentiate colors, boundaries, and symbols can retrieve the same data using alternative mode example. For example, a table. And so it's very important to provide both data view and let the user decide which one to use according to his user needs. Last but not least, we are talking about monitoring on maps. And we have here a user need that summarize all the other requirements that we talk about before this. A user wants to analyze how real-time data are changing on a geographic area shown on the map. So this is a very complex example user need because it contains a lot of numeric data, real-time update, and so the requirements are the following. Data must be available on the map as text labels or other metadata that should be updated automatically if the feature is switched on, because not every user may like the automatic update of information, but they rather want maybe to update with a refresh or with a specific user action. Also, data should be available with an alternative mode because we are talking about complex data, a lot of numeric and complex data. And for example, a table should be provided and should be very useful for a lot of users in order to read those data and be constantly updated about those informations. So I thank you again for the attention. Thank you, Joshua Connor and all the RQTF team. And thanks everybody. I hope I give you a first overview about maps and accessibility and the need for annotations that I hope it will be a start in order to think about more about accessibility on maps on the context of the web platform. Thank you, everybody. Have a nice day.
Great. Okay, excellent. Thank you, Nicolò. That was another great example of the importance of accessibility when we're talking about maps for the web. I just wanted to ask if there's anything that you wanted to add now, just before we transition into our panel discussion on the same topic.
No, I thank you everybody for the attention. I'm starting to see some comments, some nice comments and very interesting topics on the Gitter chat. So I'm ready to answer and to follow the discussion.
Great, thanks a lot. So I guess on that, I think we can transition straight into our panel discussion because it's on the same topic, and maybe that will be an opportunity for us to have more discussion, ask some questions. So maybe with that, I'll transfer it over to Gobe Hobona from the Open Geospatial Consortium, who's going to be moderating this panel to introduce the panelists. So,
actually, we should make sure that everyone's here.
Okay, so yeah, Ryan, thanks for that introduction. So let me just quickly check. So we have Doug Schepers,
Yes, hi.
Brendan Biggs, Tony Stockman, and
Hi.
Nicolò Giudice. Are we all on the call?
Yeah.
I'm here.
Nicholas, are you there?
Brandon's
I
here.
am here, yes.
Okay, great.
All right.
We're all here.
So we're all
I think
here.
we're all
Okay,
here,
all right.
yeah.
That's great. Okay, good day, everyone. So my name is Gobe Hobona. I work for the OGC, the Open Geospatial Consortium, and I'm going to be moderating the panel discussion over the next 30 minutes. So, honored to have a panel of 4 experts discussing with us today. We have Doug Schepers from Fizz Studio. We have Brendan Biggs from Audiom, and Brendan also works for the Smith-Kettlewell Eye Research Institute. And we have Dr. Tony Stockman from Queen Mary University in London, and Dr. Nicolò Giudice from the University of Maine. Welcome. So let me first of all just give you an overview of our panelists' biographies. Doug Schepers is the founder and director of Fizz Studio, an accessible data visualization startup in Chapel Hill,
North Carolina,
USA. Previously, Doug spent, sorry? North Carolina, yeah. All right. Previously, Doug spent a decade defining standards as a technical project manager at W3C. Welcome, Doug.
Thank
you. Brendan Biggs is currently an engineer at the Smith-Kettlewell Eye Research Institute working on non-visual map representations. He graduated with his master's in inclusive design in May 2019 from OGC University, where his thesis was on designing accessible non-visual maps. He's a blind web developer who has had enough vision to see a map, but not enough to use it. The main focus of his research has been on digital audio maps, in particular, maps that have been developed through the Natural Laboratory of Audio Games. He's the creator of Audiom, a multimodal map web component that can be embedded into web pages. Welcome, Brendan. Also joining us is Dr. Tony Stockman, a senior lecturer in the Cognitive Science Research Group and Center for Digital Music in the School of Electronic Engineering and Computer Science at Queen Mary University of London. His commercial experience includes working as a systems programmer at Rolls-Royce and as a systems analyst at ICI in Manchester. He has over 100 peer-reviewed publications on interaction, design, and auditory displays, and developed the tutor for editable audio maps with his research student, Esther Loliega. Tony is an emeritus board member of the International Community for Auditory Display, having served as president from 2011 to 2016. Welcome, Tony.
Hi.
And we've got Dr. Nicolò Giudice, a professor of spatial informatics in the School of Computing and Information Science at the University of Maine. He has worked for 20 years in the area of multimodal spatial cognition and the design and evaluation of accessible spatial displays, including maps. His primary focus is on accessibility for blind and visual impaired people or sighted folks and eyes-free situations. He has published broadly in this area and is on the editorial boards of 2 accessible journals. In recent years, he pioneered the development of vibro audio maps, VEMS, which are multimodal maps that are rendered on the touchscreens of smart devices such as phones and tablets. Welcome, Nicholas. So just before we get started with the questions, so Nick is an expert in vibro audio maps, and Tony and Brandon specialize in digital auditory maps. So I think it's a great opportunity for us to ask them about these concepts, what these map types are. So let's start off with Nick. Nick, in 1 minute, could you just give us an overview of what vibro audio maps are, please?
Sure. So vibro audio maps. Can you hear me?
Yes.
Oh, good.
Yeah.
Vibro audio maps are maps that are rendered on the touchscreen of a smart device, so it's a visual map that uses combinations of vibration, audio, and kinesthetic movement. So you might say, well, there's no touch on a touchscreen. I mean, a touchscreen's flat. But it turns out if you render the map and you're having someone move their hand around, when they touch a visual element, you synchronously trigger the vibration motor at that XY location or auditory cues. And the perception is one of feeling a line or a point or a region, and they can move their hand around and explore that to learn the map. And it turns out it works really well for people to learn different types of graphics. And just very quickly, you may say, well, why use touch versus audio or language? They all can work, but the beauty of touch is that it's most similar to vision and is a non-visual, of the non-visual senses, it's closest to vision, especially for spatial information like maps. So brain processes visual and tactile spatial cues, very similar. We use different areas, but the computation done by neurons in those areas is very similar. So when you want to convey spatial information, it's way easier to do it using touch than, for instance, to try to describe a map with language, which can work, but takes more cognitive load. And so there's advantages, especially when we're thinking about this as a multimodal way that can work with other people's audio renderings, but are adding touch. And it just kind of fits with how the brain processes. So it's a bio-inspired interface in that the brain is inherently multimodal. And so more devices and more interfaces, especially non-visual ones, to convey that same information need to also be multimodal. And I could go on for a long time, but I won't, because I think Gobe will cut me off. So.
All right, thanks, Nicholas, for that overview. Okay, Tony, do you want to just give us a 1 minute overview of what digital auditory maps are from your perspective?
Sure. I mean, in a sense, you could say they are a subset of vibro or tactile auditory maps. We've tended to focus on audio, and not least because obviously sound cards come with most PCs, and we wanted something that was going to be sort of globally accessible. The trick with designing these is how you're going to use different types of sound. So our requirements investigations, talking to visually impaired users, I've generally found that the really key information, if you are restricting yourself to the audio mode of presentation, really needs to be delivered with speech. So things like distance and information about turn-by-turn directions really needs to be given using speech. But there is some real value to be had by leveraging our ability to hear other sounds at the same time as speech and make use of it. And really those non-speech sounds come into two categories. One is auditory icons. Auditory icons are the audio equivalent of icons. They use representative sounds to present landmarks or points of interest along the way. So in systems we've built, we had sounds to represent things like schools, parks, swimming pools, cafes, restaurants, and so on. And the trick there is to try to choose auditory icons that are meaningful to most people wherever they happen to live. And that can be quite tricky. And we've had lots of sort of prototyping sessions where we've worked through these with different groups of people. And then the other type of non-speech sounds are earcons. These are more abstract sounds, and they're abstract because you particularly don't want them to be confused with auditory icons. You don't want people mistakenly to think that they represent a point of interest. So they are deliberately not natural sounding particularly, but they can be used to convey other bits of information about the route. Typically, possibly things like how many degrees are associated with a particular turn. I don't mean literally down to 1 degree, obviously, but maybe breaking down the 360 into say chunks of 45 or 60 maybe. So ear cons are an important contributing source of sound in auditory maps, and overall the skill in developing a good auditory map is how to choose the sounds that are going to be most effective, and balancing these different types of sound so that they give an engaging and usable experience to people using the map.
Gobe, would you mind if I give 30 seconds? Those are both excellent explanations, but do you mind if I give 30 seconds to people who may not be familiar with accessibility in general, how blind people, for example, will use a screen reader? Just
Sure.
Very briefly. The two techniques that they talked about are supplemental and in some ways in contrast. So with what most people, with the typical modality for browsing the web that a blind person will use, which is by a screen reader, and a screen reader is a piece of software. If you're not familiar with it, a screen reader is a piece of software that it's a bit like an audio book, but interactive. So you can move around, you can search, you can find things, you can find the table of contents of a page. It announces links, it announces alt text for images, things like this. But that is for textual content. You can apply that to visual content. For example, reading out the image, the alt text of an image. But when you have complex images like maps, things that, or data visualizations, charts, etc., that you're meant to actually visually explore, that's where the techniques that, in addition to hearing the speech things, that's where these vibrotactile and auditory maps really shine. So a combination of these things, all of these techniques, is really what's sought here. And I also, one thing I want to bring out is the techniques that they're talking about aren't necessarily going to be things that need to be enabled by the, or specifically enabled by the authors of the map. They might be things that are supplemental, that are additional pieces of software, assistive technology that goes on top of a map that is properly annotated as per the last presentation and is properly marked up in such a way that it can be consumed and transformed into these modalities, right? It can enhance these modalities. It can enable these modalities. So you don't necessarily need to make your maps vibratory or audio tactile, but you should make your maps amenable to using those techniques.
Okay, thanks, Doug. Brendan, in chance you could give us just a 1 minute or so overview of digital auditory maps from your perspective.
Yeah, absolutely. So there are two different types. Tony gave a really good summary of digital auditory maps, but I think there are two different like overview types. There's interactive auditory maps. So those are the ones where you are have like an input device and you're moving around the map, very similar to like a game like World of Warcraft or something like that. Then there are presentational maps, and so those are like recordings. And Tony's been working on these specifically. You basically listen to like an overview of a map, and you get all the different turn-by-turn information, or you get information about the map as you listen to it. And so the only interaction you have there is you can fast forward and rewind. And so I think those are the two main types of maps, and they each present different information. But in my research, the interactive maps have been what you can present information such as shapes, routes, like getting route, landmark, and survey knowledge very quickly. And I think surveys are what the presentational maps are really, really good at. So I think you need kind of a mixture of both. And but you can have both, which is what's really nice about auditory maps.
Okay, thanks, Brendan. Okay, so let's move on to the next question. So with all these approaches to creating accessible, auditory maps, what is the biggest challenge that you see standards development organizations needing to face, but not just standard development organizations, but also browser developers? What's the biggest challenge that these organizations will encounter when they attempt to, develop standards around those types of maps? Shall we start with, let's start with Doug.
Oh, I think I sort of summarized part of what my goal there, which is to say, I think it was an excellent presentation. There have been several excellent presentations on extending the web to do different things around accessibility in terms of maps throughout this entire workshop. I really liked the annotation one that immediately preceded this panel. I recommend people watch that. I think that we're fortunate now. We've got a pretty rich platform in order to, for example, we can enable vibratory maps. I don't want to step on Tony's toes, but we can enable vibratory maps because we have the web vibration API. We can enable the auditory maps because we have the web audio API. So some of the base features that are needed to enable the modalities that we're talking about are already there. I think that one of the next steps is for us to have standard ways of representing particular things, whether that's an ontology or it's just loosely based on text. Basically being able to say that something is a restaurant, and from knowing that it's a restaurant and knowing the geometry, et cetera, of an area, you can actually work out client side. You can enable a lot of features client side. I think it's going to be a combination of web standards, features that already exist, perhaps either ontologies or vocabularies like ARIA, specifically around maps, and then probably a lot of experimentation by pioneers like these guys who are really making it work on the client side, and then probably that would need to be folded back into standards going forward. I think it has to be a combination of standards plus innovation in the in software.
Okay, all right, thanks, Doug. Okay, Brendan, do you want to just share your thoughts on what the biggest challenges that standards development organizations and browser developers will encounter are?
Yeah, I think there's three things. One is the data there needs to be a lot more work with data. The second is the APIs. There are some future APIs like with XR that are coming out, and we need to be thinking about those and how we can represent maps in that way. And the third is getting the users involved in whatever we make. So whether it's maps, these accessible maps, getting people who build these accessible maps involved with how the data should be represented, or if we're actually building these interfaces, we need the users to be experiencing those. For the data specifically, I think there should be like a name. Every single one of these interfaces that we've talked about requires a name attribute or a label attribute, very similar to what the guy in the last presentation was talking about. And that's just super critical. And then another big issue that we need to be considering is raster data, because extremely difficult right now for us to represent raster data in any Vibro or audio maps because it's just a picture, and pictures are completely useless for computers. And what we're doing essentially is translating the data and using the computer into a different modality. So pictures are inherently visual, and so if we can get the underlying data from that picture into something that's more useful, that's going to make the digital auditory maps and vibrohaptic auditory maps more useful. It'll actually be able to use that data. It'd be like using a recording and making a picture out of the recording. So we need to figure out a way to make raster information into some sort of vector, getting some sort of vector geometries. And then for the APIs, there's like these tactile gloves that are coming out that should be in the next couple of years. And those will allow for 3D model maps, which we don't have right now, or raised line maps on like a piece of paper virtually. And so we need to be thinking about having APIs for these types of peripherals for XR. And it won't just be for maps, it'll be for a whole bunch of other things too, but maps will definitely be part of that. And then we just need to have lots of testing. So those are what I think are the 3 things that we need to be thinking about for going forward with these interfaces.
Okay, all right, thank you, Brendan. Okay, Tony, you want to just respond to that question, please?
Yeah, I think from my work and my point of view, one of the real problems actually is the lack of standards for auditory displays in general. I have been involved with the international community for auditory display for quite a while now, and there simply are not standards for the way we represent things in audio. There's some things that are known to work relatively well, and there are guidelines for some specific elements. For example, the ear cons that I talked about towards the end of my minute just now. But in general, there's a real shortage of standards. And I think that's really a challenge for the auditory display community to try to address. Touching on the presentation we had on accessible maps, which I agree was excellent, I think as well there is, and a little bit about what Brandon said about overviews. One of the limitations of the work we did on interactive maps was the fact that you couldn't easily flip views or interact with the map at different levels. The system we implemented and allowed somebody to effectively virtually walk along a route and encounter points of interest along the way, but you couldn't kind of zoom out of that view and traverse the map easily at a higher level, at a more rapid rate, and gain more of an overview of what was there. And that, to some extent, is what our current work is looking at. And then finally, I'd very much endorse what Brandon said about getting users involved. We've learned an awful lot about things to do and not to do concerning auditory icons through prototyping with users, and I think that's got to be a key part of the way forward.
Okay, all right, thanks, Tony. Nicholas, would you like to respond to the question, please?
Sure. So Tony and Brandon have hit a bunch of the points that I would make, but I guess what I would add here is that there needs to be, especially for these non-visual variants of maps that most people haven't, cartographers and map producers and designers haven't thought about auditory and vibrotactile. And so we need to somehow bake into any type of standard more empirically derived guidelines for that, for design that really maximize or ensure that these elements are both perceptually salient and cognitively meaningful. And so, we have lots and lots of information out there about things in, map elements and line thicknesses, and I mean, there's a huge array of visual parameters that are just guidelines for design, but that make a big difference in how the map is perceived and learned and remembered. None of that exists for these non-visual maps, and the parameters are different. You can't take a visual parameter and have it work for touch, because touch has 500 times less sensory bandwidth. So we have to figure out, we have to do kind of the low-level psychophysical work to figure out what are the, what is a line that is most perceivable, what are the thresholds, when is it maximally readable, things like that. And I think to do that work, which has started, and people, including some of the folks here, we've started doing this, but for a standard to be meaningful and to actually work, we have to be able to have these really well clarified. And also, Tony and Brendan both hit on this. At some point, we need to think more about what I think of as the information modality mapping. So when we're developing a map or any non-visual multimodal graphic, what properties, what attributes should be rendered by which modality? So it makes sense to give labels and distance, and as Tony talked about, direction and things like that through auditory cues, but perhaps the actual geometric layout information might be through space, but that mapping isn't clearly specified. And I think that will be really important for success with these types of maps.
Okay, thank you, Nicholas. Okay, so I'm from a standards development organization, and one of the first things that we do within that community is we research a particular area of interest and try to understand, what the issues, the requirements, and needs are around a particular topic. So my next question to you is, can you please suggest ideas for experimentation that could improve understanding of the issues surrounding auditory maps and accessibility of web maps in general? Help us to prioritize our thinking in terms of where we should focus our innovation work. So shall we start with Nicholas, please?
All right. So I kind of already gave my answer, I guess, in the last the last answer.
Okay.
But the experimentation that needs to be done is stuff that's been started, and it really hits on those points that I'm doing. But it should be done with users, as Brandon has said, and I think it also needs to be done with it's not just getting the data that I talked about, but how to get that information to other map developers and people that are doing web-based mapping to learn how this type of thing can be implemented. They're obviously not going to be experts in using vibration, but if we do this right and get very clear parameters and guidelines, these are things that can be used in generic application of maps. And I think it's as much doing the experiments as getting the data and the results out to other people that can use it that's important. And I think that link is currently not always the case. And I think that's an important part going forward.
Okay. All right. Thanks, Nicholas. Tony, do you want to respond to that question?
Yeah, sure. Really comes back to what we were saying, I think, about involving users and finding out what works in our case in audio. So I talked about presenting some information in speech and other information being presented in non-speech sound. And quite often this can be done simultaneously and somebody can understand both streams of information. But there needs to be more work done on this to know what kinds of combinations of sounds presented simultaneously or very close to one another in time work well, and what can people take in at any one time. And particularly picking up the point I made about overviews or the ability to switch between different levels of map navigation. As you zoom further out or get a higher level perspective on the map, it may become necessary to present more information within a relatively short time period. So knowing what it is that that people actually want to know from a map overview how best to make that overview configurable so that people can actually specify what elements they want to give emphasis to, and the means by which emphasis should be given to certain elements. So it's really effectively user investigations and exploring these different options and what combinations work well.
Okay, all right, thanks, Tony. We're nearly out of time. Brendan, you're up next. Would you like to respond to that question?
Yeah, sure. So I think really the biggest thing that needs to happen is we just need to make more maps in all different types of modalities. I think right now the biggest problem is that we haven't really tried doing BART maps or topological maps of the Grand Canyon, or different types of maps that are required for being a professional geographer, and doing all the different types of maps that are out there. So I think that's really the next step, is we just need to make a bunch of different maps, and I think that's what we're trying to do with the Audiom platform that I'm working on. I know all of us here, Tony, Nick, and I are really trying to make different types of maps. So I think that's we're kind of doing that, but it's taking a little bit of time. So yeah, I think that's what needs to happen.
Okay, all right, thanks, Brendan. Okay, Doug, would you like to respond to that question?
Really quickly, I want to reiterate what everybody else has said, which is we need user testing. For example, I know limitations of standards. Oftentimes there's not a lot of user research and real world data that goes into it. Everyone tries, it's good faith. But for example, the color contrast ratio enshrined in WCAG for forever is a little bit arbitrary. It's not really hard data. And I know this is being improved in WCAG 3, but I really think that there needs to be concerted user research like these other folks have said. And I also, to reinforce something that Brandon said, different tasks, different kinds of maps have different tasks associated with them, different goals, different things you want to do with them. And we need different modalities to deal with that. And so we need to identify those tasks that each type of map, which tasks you can accomplish with each type of map, and maybe work out how best to accomplish those things. But again, experimentation, as everyone said, and user research, and incremental changes to some of the existing web standards that we have. And also in pushing out, making sure people understand that they need to make the data available so that these modalities can be enabled through their maps.
Okay, all right, thanks, Doug. Okay, yeah, so that's all that we had in store for the panel. So I'd like to thank our panelists for this session: Doug Schepers from Fizz Studio, Brendan Biggs from Audiom and the Smith-Kettlewell Eye Research Institute, Dr. Tony Stockman from Queen Mary University, and Dr. Nicolò Giudice from the University of Maine. Thank you for sharing your insight and discussing with us on this very important topic. Thank you. Brian, I think it's back to you.
Yes,
thanks,
great. Great, thanks everyone, and thanks Gobe for moderating that excellent session. So next we're moving into a set of presentations related to advances in 3D map display. So first off, we're going to have Jan-Erik Vinje, who is the Managing Director of the Open Air Cloud Association, and also a full stack developer at Norcart AS. He's also a co-chair of the OGC's GeoPose standards working group. And he's going to be giving a presentation titled From Points of Interest to Maps of Objects. And I have Jan-Erik's presentation here, so I'll just share my screen and we'll start running through it. Okay, should be able to see it now. And
there we go.
Okay, so take it away.
Thank you so much for the opportunity to speak here. can go to next slide, actually. Are we seeing, do you see all, okay, it's just cutting off a little bit in my Zoom, but that's fine. Yeah, I'm the managing director of OpenAir Cloud, and we are working on driving the development of open interoperable technology data standards to connect the physical and digital worlds for the benefit of all. And we got a couple of, amongst our members, we have a couple of dozens who are contributing as volunteers on a fairly regular basis. And we have a steadily growing number of partner organizations from the spatial computing industry. Next slide. So straight to the topic, we're now going to look at how we can go from points of interest in maps to interesting objects in maps. To look into that, we might want to do a comparison of the two. So next slide. Points of interest are very familiar to most people who have worked with maps. Typically, they refer to something by their position, and that position, in most cases, is a 2D geographical position. It could be latitude and longitude or some other geographical coordinates. They can represent very different things. So typically, it could be like it could be referring to a city, and then there's one single point that refers to that city. So it could be a large area, but it could also be a stationary object like a building or a statue or something of that sort. And then you could also have dynamic poise that where you have, for instance, vehicles or people who are moving around. Poise tends to have a few common attributes. You have categories, you ID them, you name them, and very typically you find some generic symbols. So the category tends to inform what kind of generic abstract symbol you use to represent the points of interest. And then there could be any sort of metadata. Electric vehicles, they are a very interesting case of POI data. It could be very rich. You could have images of the charging station. You could have, I'm talking about electrical vehicle chargers. You could have images. You could have the status of different chargers, if they are available or not. Any kind of thing. So the world of poise are quite large and complex and interesting. Objects in maps share many of those features, but you need to go to the third dimension when you're talking about an object. And if you want to have them in a map, you need their real-world geospatial pose. You need a 3D geospatial position and orientation. Which allows for 6 degrees of freedom positioning of the object. Also, something that is different from some types of poise objects, they have a limited 3D volume. They have bounds, and most often you would say that they have unique 3D geometries per object. Not always, but that would be quite common. And you can then allow to visualize the concrete and specific. That makes them more direct and less abstract and generic. You can use to represent any real or virtual object with a 3D volume and a real world pose. So that way OEMs, they can represent a subset of poise, but do that in a way that is more spatially accurate, and also they enable new ways to use maps, like immersive maps. And a little note here that as they share so many of the attributes of points of interest, if there were a standard for poise, you could easily extend it to define objects in maps. Next slide. So yeah, this is a little bit of the lamenting, because there are no standards. OGC tried a brave effort. What you see is that companies like here and Google Maps and Nordkart, my company, we handle POIs in different ways. We try to assemble different sources of POIs from a range of sources. Maybe you write wrappers, maybe we write our own idiosyncratic POI services. Maybe the closest thing out there in the real world could be the point feature of GeoJSON. It has a coordinate here. In this slide, you see it as a 2D coordinate. It even supports 3D coordinates. And then you have properties where you could essentially put in all the metadata of the POI and set up the categories or IDs and that kind of thing. But that's not really, that doesn't really cut it. Okay, so next slide. For talking about objects, I want to take you back to the time of paper maps. Next slide. Next slide, yeah. So this very beautiful map from Paris. Oh, previous. Go on back. A very beautiful map from Paris. You see, actually, you see the buildings and trees and different things as three-dimensional objects in the map. It's a very rich way to visualize a place. And we see that if you go to the next slide, here you see this kind of approach is still being used. Theme park maps tend to have this way of representing. It's a very intuitive way to understand, navigate, and find what you're looking for. Interestingly, here there's a combination of objects that are specific and idiosyncratic, and then you have the generic POIs. You have those numbers and letters that are more abstract. Next slide. So now we want to return to digital maps. Next slide. There's something going on right around now. It's been going on for some time, but map data is becoming more 3D, and by going in that direction, they can start to break out into the 3D world, out from the 2D screens. So if you're looking at the starting point, we have POIs on 2D maps. Leaflet is a library for web maps that displays flat 2D raster tiles. You could put POIs on top of that. Then they are in the realm of 2D coordinates. Then there's an evolution towards vector maps, where, for instance, Mapbox, they have vector tiles. And you could also tilt those maps that are essentially flat, but by tilting the map, you get this intuition of the 3D aspects of distance. So things further apart comes closer together. So it's a great thing, but the 3D aspect is limited to a flat plane where you might do some extrusions, and you you have a richer way to interact with the essentially 2D flat map. More interesting though are the globe maps, where the real world is recreated 3-dimensionally on the screen, and where you can place objects in those maps with geospatial 6 degrees of freedom position and orientation. What we call GeoPose in OGC and also OpenAir Cloud. That's all great. This is real world spatial computing, 3-dimensional, but in OpenAir Cloud and in the industry, spatial computing industry, we want to bring the map data out in the real world to create immersive maps that we are in the middle of, and we interact in the way we interact with the real world. So OpenAir Cloud is engaged in this technology of real-world spatial computing, which is more or less an infrastructure that it would be based on real-time updated 3D maps that are in the cloud. Next slide. So I mentioned GeoPose, geospatial position and orientation. I'm working with Christine, she will be speaking after me on the OGC standards working group to define a universal standard for geospatial position and orientation. We've been working intensely since January 24th, and hopefully we'll be able to publish a draft specification that can be reviewed by the community. Next slide. OpenAir Clouds, currently we are hoping to use this standard in our big project now. We are working on something we call the Open Spatial Computing platform that we hope can enable what you could call an open spatial web, and also provide an interoperability layer for real-world spatial computing in general. And it's the most fundamental piece of that platform would be GeoPose. And then there's the machine readable world, and discovering all the types of content and services related to the space around you. And next slide. So when we're talking about the spatial web, it is very much a map concept where those who have worked with maps all their time, they can recognize the bottom part as base layers. The base layers in this concept are tied to the real physical world. It is the terrain, it is the buildings. But in addition to what is typically the base layer, there's another aspect of reality that becomes part of this base layer, and that is the dynamic part of the stuff that is moving around. That is why this kind of map is not handmade, it is machine made. It is based on machine perception and reality capture using sensors. It doesn't exclude some manual intervention, but the real-time layer would not work without reality capture and machine perception. On top of that, there are thematic layers. That would be the kind of layers that might be transparent, that contains extra information that you overlay on your base map. But now the base map is three-dimensional, and you're inside of it, and the overlay is all around you. So that is sort of the main difference. You live inside this map. So next slide. This talk is about object. Oh, you jumped two slides. So the first I want to mention that on the bottom here, when you want to represent things in the real world, you want to represent objects, and you can then combine a set of 3D geometric data with the GeoPose, and that can be used to have your both static and dynamic reality layers. Those are the real things, and the things that are made of atoms that you represent, the base layer. But you have other types of objects that aren't always part of the real. So you can go to next slide. Those can be anything that could be virtual, could be something from the past, something from the future, something an artwork at your location. It can be something abstract that conveys some information about the place. So you will be able to benefit from using objects in map throughout this, all the layers of the spatial web. Next slide. So bringing this back to W3C and web standards, I already lamented on the lack of a standard for points of interest. So somebody should pick up that. So maybe W3C and OGC can get back together and figure that out. And if you go to next slide, I have my thoughts on objects in map. Browser support for objects in map should use the OGC GeoPose standard. and also support automatic transform from geospatial to Cartesian. Currently, the proposal we're working on in our standards working group has something called a basic GeoPose, which is in latitude longitude, and that doesn't really work too well in screen coordinates or in a 3D in a 3D scene that is rendered using 3D graphics. So there is always this need to make the transform from the GeoPose and over to Cartesian. So this kind of support should be part of any kind of native maps API. And in the native map elements that is being discussed, there are especially two modalities where objects in map becomes especially useful. So that would be if we could make sure that the map element supported a globe mode, like you see with Cesium or Google Earth, and that kind of engine. But also, and then maybe even more so when you go for the immersive modes, where you can pull the map up to 1-to-1 scale and view it from virtual reality or augmented reality. And in particular, that's where the last point here comes in. When you're in, for instance, a web XR immersive modes, if you use just GPS and compass from your device, you might fall a bit short on the accuracy. So AR cloud technology tends to leverage an AR cloud map representation of the world for positioning. And OpenAR Cloud is working on developing a universal protocol where clients can speak to AR Cloud positioning services, what we call GeoPose services, to obtain the device pose. Then you might end up with centimeter or a few centimeter accuracy at the current level of technology. And if you have your device pose, you should be able to display object in maps at their real world locations. And that is really from maybe what some I've heard. There's this expression in the AR cloud about painting the world with data. And one of those data could be those objects. So that is a hope for the future. Thank you. I think now over to Christine, and you will be able to learn a lot more about GeoPose.
Great, thanks, Jan-Erik, for that excellent presentation. It's interesting to see some of the requirements and needs for this transition to more 3D space and augmented reality for the geospatial web community. So that's excellent. Yes, and as Jan-Erik mentioned, so now we're moving on to a presentation, our next presentation in this session, which will be given by Christine Perey and also Josh Lieberman. So Christine is a consultant from Perey Research and Consulting. She's also a member of the OpenAR Cloud Association, and with Jan-Erik is co-chair of the OGC's GeoPose Standards Working Group. Josh Lieberman is a director of the innovation, one of the directors of the innovation program at the OGC. So feel free to go ahead. I don't have your presentation, so I'm not sure if one of you wants to share your screen.
You don't? Oh, we provided it to Peter, and he's uploaded it. Okay, Josh. Wow, what a beautiful background.
Something like that.
Perfect. Actually, while Josh is doing this, I want to thank everybody and thank Jan-Erik for setting the stage for this. What Josh and I wanted to do is actually respond to a request that Peter made of us months ago. I think it was a request on behalf of the committee running this, this workshop, that we share with you how GeoPose supports the new web map, use cases and requirements. Josh, could you go into full screen mode, or is that what you have? I see the, oh,
it's a
that's
very
perfect.
large screen. Hopefully it still works.
Yeah, it's just fine, just fine. So what I did as a first step is I went into the document that was provided by Peter, which I'm sure many of you are familiar with, for describing the use cases and requirements. And I pulled all of those out, the use cases and requirements, the functional requirements, and then made them into tables. And that's going to guide us a little bit, or at least that's the origin of the structure of this presentation. But before I do that, I think you could go to the next slide. We'll be focusing primarily on the alignment between GeoPose and WebMap. But before that, I'll give a few minutes on GeoPose. And then hopefully we'll have a little time, and we're going to transition into a discussion after this for more use cases and maybe showing and talking about where things go next. One of the things I want to emphasize here is that GeoPose and the concepts that we're going to be discussing are 3D at their core, just like objects imply and really have a 3 dimensions in Jan-Erik's presentation. That's the case here as well. The second big concept is the way we've broken these out is we're looking at 3 actors or audiences as they were defined by the WebMap activity. So we're looking at the content creators' roles and their needs, the visitors to websites and maps, and then the developers of applications that combine content and maps and deliver services to users. So we can go on to the next slide. So you've heard quite a bit already, but it's important for us to reiterate what is GeoPose. It is in Cartesian coordinate or Euler coordinates. We've actually advanced this and going to provide that as an option. And it's anchored on the surface of the real world. There are a couple of different concepts that allow us to extend from the simplest frame to nested or advanced frames. We include some concepts around time and sequences of frames. And it's quite a rich conceptual model. But again, as I come back to the core of this really is about placing objects, whether they're real, virtual, or symbols, into projections that are oriented at 6 degrees of freedom for accuracy and richness. Next slide, please.
I just make a quick comment here, because there's this thing about frames here that may be confusing. And of course, the basic part of this is orienting an object, but the way that's done is by fixing a frame of reference. And as Christine said, a Cartesian or possibly Eulerian frame of reference, but you're fixing this frame of reference to something. For a GeoPose, one of the 2 frames that is providing that position and orientation is fixed to the Earth. It can be fixed to another celestial body, right, for Seleno pose or so on, but for now we're talking about the Earth. The other thing, though, is those frames can be fixed for different purposes. So the base purpose is there's some object, virtual or physical, and the frame is attached to that object, so the object's position and orientation can be determined by the GeoPose. But the frame can also mean a couple of other things, and this is relevant to the WebMap cases. It can be relative to an observer's ability to see. So it can essentially represent the user viewpoint, where they're looking from, what they're looking at in a 3D or 6 degrees of freedom perspective. Or
I think
it can be,
the next slide shows that, has the figure showing that.
Yeah. So so it can be the viewpoint looking at or the perspective looking from. So let's go on to that.
Exactly. Perfect. And so we're certainly happy to come back to this figure if needed to show that, again, the user is, in this case, in this particular illustration, the beneficiary. But I also want to point out that there are a lot of machine-to-machine use cases for GeoPose, which are not exactly in scope for this particular workshop, but the use cases are diverse in time and space and devices. So let's go to the next slide. As I said, we very much followed the framework that was provided in terms of these 3 categories, and in our case, you know, the assets being published into some sort of a server where the website visitors can get them, but also the application developers can use those to enhance their runtime applications. Can you go to the next slide? And I think, Josh, your our thought was perhaps you could explain a little bit more what we have on the right-hand side of this table. In general, you can see, though, that GeoPose isn't necessarily relevant for all of the use cases that were outlined, but some.
Yeah, I mean, the idea here was to take the use cases that have been defined and presented for these different roles dealing with web maps. In this case, an author of content to be displayed in a web map, and look at where GeoPose might play a role. And so here there is a kind of an idea for a role for specific use cases. For example, displaying a map centered on a point location, so that you can have a location, an orientation, and a scale of that map. And you want that to be most appropriate to a particular user, and that's generally the user's viewpoint. And as we mentioned before, one of the roles that GeoPose can play is to express a user's viewpoint. In fact, a sequence of GeoPoses can indicate a user's progress, for example, taking a tour or changing their position, and being able to display a map that has content for that viewpoint. That can extend, for example, to displaying a route. So not only saying, okay, we have some sort of assumption that indicators are aligned according to the route, but we can actually have objects relevant to the route that are aligned in the map as someone on the route would see them. And as far as displaying custom web content, that's the same thing. So being able to symbolize or mark objects, they may be points of interest, but we can exactly use the GeoPose to show this is the orientation in which you would see that building or that other feature as you encountered it along the route or from a particular perspective on the route. And that extends then into creating layers by assembling those objects, which may be coming from many different places around the world, but using GeoPose, they can be placed relative to each other and within the extent of a map layer. Extending that further in time, then the use cases of providing animated spatial data, the animation, for example, of position and orientation can come from a sequence or stream of GeoPose objects that position that, although within a 2D map layer, the 3D position and orientation can be shown. So there are particular use cases here where it seems there's a useful role for GeoPose. And we sort of sum up that in, we'll call it the content, the GeoPose assisted creator paradigm. So there's positioning content in a map using GeoPose. There's positioning a map according to a user viewpoint, or assembling a map layer from diverse features, each of which has their own position and orientation, and then being able to have that change over time by the injection of updated geoposes for those objects. So the second stakeholder or actor is the visitor, the user, the viewer of this sort of web map. And we have, again, this ability to have one's viewpoint tracked, you know, whether that goes to a server or just remains in the browser, which then, you know, provides instructions. I want to see this map plane orientation. And the ability, for example, for a user to say, here's a point with, you know, one of those little carrots on it. I wonder what it really looks like, or what's more information. So being able to pull more information, which includes, for example, a batch model of the gas station and its orientation, you know, how you would see it as you came up to it, seeing that perspective in the map. So another way that this provides information on a map is to provide 2 or 3D filtering, even within a 2D map layer, to be able to say, for example, searching or sorting within a set of features in a map layer, you know, what's at ground level, or what's higher up in the air, or what things can I see, what things can I not see because they're hidden somewhere else. And so even in a 2D map, the GeoPose information, you know, what signs are facing me versus I'm not going to be able to see them, can be derived from the GeoPose information. So there's another bit about here, comes under the category of what really is a map. And so we think of a map and things like augmented and virtual reality as being very separate. But there's another perspective in which, you know, a map is really let's say, a basic aid to visualization. And so we don't really talk about this as imagination or creativity. We talk about this as, well, to use a map, you need map skills. But map skills are, how do you, in your mind, take symbols from this flat piece of paper and insert it into your picture of the landscape that's presented before you in order to find something, to navigate something, to undertake some other task or learning with regard to that landscape. And so there really is a continuum, is my assertion, between a flat map oriented north with a fixed extent and scale, and something which becomes more adaptable, more responsive to that user's interests, viewpoints, perspective, and progress. You know, so we're looking at the sort of other end of the spectrum of, you know, so far, of augmented reality, where you really are looking at what's around you and in front of you and having those map objects placed into that view, but having a web map that is portable and is able to sort of transition from that augmented reality to mapped reality to mapped formalism of reality, is a way that can really be put into this spectrum of use. And GeoPose, so that 3D position orientation information, is an important part of establishing that continuum. Okay, yeah, so orient and scale a map to my viewpoint, retrieve and view detailed objects for points of interest, filter content by the positioning. and orientation. And then as well, having this standard bit of data about where that object should be enables, facilitates the offline storage of those objects. And in fact, enables, for example, them to be updated with small amounts of positioning information to minimize the bandwidth, for example, of updating that content. So the third one is the application developer. You know, what capabilities can a developer create using the assistance of the GeoPose definition of position and orientation and the ability to exchange, interchange, and manipulate that. So here, for example, ability to provide feedback to users as they manipulate the map. So ability to show where that map plane and the map viewpoint is positioned, for example, in the user viewpoint. So that, you know, where am I looking at in the larger context, but in 3D. Moving the map to a new position or zoom level. Again, going from the flat map, which we've kind of reduced to say, okay, that's a map. But what many people have shown us is that there has been for centuries this desire to create maps that are on user perspectives, you know, the map of Paris and so on. It's just that up until fairly recently, those maps have been quite difficult to compute. So we've taken the, you know, sort of GIS flat map as that's what a map is, when there's been a much more flexible, a broader perspective of what a map is through time. It's just required really clever capabilities to do that. And then looking at being able to generate new vector features. So having GeoPose as an interchange format enables you to take data, use that positioning from, you know, myriad sources and create new vector features. And in fact, update those features, for example, by being able to drag and drop a GeoPose object. You know, this is where it is now. And, you know, have the map update according to input of these new GeoPoses or GeoPose sequences. So leveraging the user GeoPose, using GeoPose sequences for animation, generating new features from data including GeoPoses or even GeoPoses linked to features already there. And, you know, here's an idea. You can drag and drop those GeoPoses to animate map features. Say, you know, okay, here's where it was then, here's where it is now, here's where it's going to be later. So there are, this is just the start of new ways that you could use GeoPose to extend the web map paradigm, you know, in some ways that are new, in some ways that are just recovering what cartography used to be able to do, but required, you know, the cartographer to sit in your phone and do that. Okay. Do you want to talk about these functional requirements, Christine?
You know, in the interest of time, I know we've got a panel coming up. I think we should maybe move right to the third one, because that's where the greatest value lies. So
these are our particular capabilities that have been derived from those use cases. And similarly, we've gone through and said, well, there may be some interesting ways to use GeoPose. And I'll just note, you know, being able to use images not just as geo-rectified images, but actually show the swath or path of image acquisition is a possibility. And then many of these are similar to the ones that we've inferred from the use cases themselves.
Exactly. Yeah, and I think that this really brings it home. I mean, since the requirements were driven by the use cases, we they matched, and you did a great job of explaining those use cases. So we think that there's a lot of potential for GeoPose in the web maps, in the implementations, not only the ones that the use cases and requirements that were envisioned, but that people will certainly be using this capability, invent new ways of using maps. And that with the GeoPose, they'll be able to not only position orient objects, but specifically with respect to a user, and also be able to see where and how a user sees things from the user point of view when you're designing applications and so forth. The remarks that we made were organized really to keep parallel with the use cases and requirements document. And I think that's shown here. So content authors will be able to enrich what they have to offer using GeoPoses. Visitors will not only have a different and additional experiences of their existing maps and augmented reality, and maybe being able to walk in a map, walk through space in a mapped way. And finally, there's a lot of applications and potential for developers to not only use simple GeoPose, but our sequences and animations, and really enrich the use cases. So again, as Josh also mentioned, the idea of dragging and dropping some GeoPose data into view, and how is that going to enrich the experience and make it more meaningful, and perhaps give us new ways of thinking and looking at the world. I believe that's all we have. Thank you, Josh. Thank you, Ryan.
Great. No, and excellent. Thank you, Christine and Josh, for that excellent presentation. So as Christine mentioned, we're about to start a panel discussion where we'll get into more of this 3D content, and also a little bit on augmented reality. So I guess we can start that now. So I believe that all of the panel members are here. So maybe I'm just going to introduce everyone. So maybe as I go through the introductions, you can just show your video and wave at everyone or something. So I guess just to get started, so first off, so the panel consists of a few different individuals. We have Christine and Jan-Erik, who everyone's just met through their presentations that we just had. We're also fortunate enough to have Ada Rose Cannon, who is a developer advocate and staff engineer at Samsung, and is also a co-chair of the W3C's Immersive Web Working Group. Patrick Cozy, who is the CEO of Cesium, is here, as is Thomas Logan, who is the owner of Equal Entry. So I'd like to thank everyone who's made themselves available today to participate in this panel, to provide their expertise on augmented reality. So maybe what I can start with is, I was interested if any of the panelists wanted to provide any opening remarks before I get into questions. If there's anything that you wanted to say about what you do and your expertise on augmented reality, that would certainly be welcome. Or we can just transition into questions. It's really up to you.
I'd love to just say a quick thing about kind of my area of interest for augmented reality. So I'm Thomas Logan, coming to you from Tokyo, Japan tonight. That's why it's very dark here right now. But I own a company focused on just improving technology for people with disabilities. And I guess my specific area of interest, I went pretty deep on. It's not that broad, but it's a big problem for people with disabilities, is the accessibility of crossing at busy traffic intersections out in the real world. So I wanted to bring into at least a discussion, even with augmented reality, a lot of times there's thoughts of the visualization only part, but the sonic sound components that can be put into augmented reality are very interesting for people who are blind and low vision when thinking about knowing whether or not it's safe to cross intersections. So I had done a project with New York City where of 40,000 intersections they have in New York, only about 550 of those have that beeping tone locator to tell you when it's safe to walk or not. And I just bring that in as like something I think interesting to have as a user scenario. We were talking about use cases in the previous one, but I think thinking also about the audio components of how this map data can be interpreted is very exciting. Nice to meet you.
Thanks, Thomas. I wanted to bounce on that. I think we often overlook audio augmented reality, and it is a field, but we can come back to that.
Would anyone else like to mention anything as an introduction, or we can go into questions if everyone's ready?
Yeah, Ryan, if I could just chime in quickly. So yeah, one is just, thank you for inviting me to the event and to be on this panel. And then just a quick intro for myself. So I'm Patrick Koza, the CEO at Cesium. I do a lot of work in the open standards world. I chair or co-chair the 3D formats group at Kronos, creators of the GLTF format. I'm really excited for augmented reality. I think that it's going to be a huge paradigm shift to how we experience computing, right? Thinking about the screens on our phones and our laptops of today and what that means tomorrow and 10 years from now. And I'm really excited about the intersection of maps and AR as kind of some of the main killer use cases in bringing temporal 3D to this. So looking forward to chatting with everyone today.
Great, thanks. Thanks, Patrick. Okay, so maybe we can get into questions if Jan-Erik and Ada don't want to say anything at this point, but and I would like to just encourage our audience who's listening to feel free to ask questions in the Gitter chat. I do have a few questions to pose to the panel, but if there's something specific you want to bring up, please go ahead. It's you're the ones we're trying to speak to, so if your questions are certainly important. So maybe the first question that I was thinking of asking, and I think part of this might have partially been answered by the previous presentations, but I think there might be opportunities for some other opinions. I was thinking that I guess 3D and augmented reality really represents a fundamental shift in how the geospatial web communities think about displaying information. I know especially for the geospatial community, I know myself, it's this community is still fairly focused on two-dimensional representations of content and analysis. That's how the communities traditionally work, and that's where its expertise is. So I was kind of wondering what you think these communities need to consider when they're thinking about standards for developing augmented reality in 3D maps. And maybe we can start with Ada in this case.
So I think some of the stuff you, so like speaking as someone who does run one of these groups for putting standards together for AR and VR on the web, focusing on AR for this session. The thing which I'd like to focus on is working out the things which where there is some almost overlap with features that are required, by finding the bits where we can extend the existing WebXR device API to give access to the information you need from the hardware to display the content. Because the WebXR device API is very low level. It's pretty much raw access to like the sensor data from the headset and access to display stuff on the headset itself. So finding the bits where getting access to this sensor data or to the displays would be really beneficial.
Yes.
Oh, that's an excellent point. I think is getting that sensor content to be able to make it usable for these applications is certainly important. I just wondered if anyone else has a follow-up to that or to the original question.
I think that makes very much sense. So we're currently deep in the nitty-gritty details of of what we want to develop in OpenAI Cloud as a protocol for obtaining your GeoPose from a service. And that method starts with the sensor data from the device, and we need to find ways that we can negotiate with the server how we can send that sensor data and what sensor data the server needs. So we want to leverage what else is in the standards community around sensor data, and then be able to communicate that, get access to that data, and communicate that data to a web server, and then be able to get it back and treat it almost like a new type of sensor data that has been refined, that is more accurate than the original sensor data for the purposes of something like pose. So then you have a protocol for a GeoPose server, and that would be an awesome thing to include as a protocol for use in the web context.
I just wanted to add in, like, I guess echoing on Brian's point about a lot of government agencies or governments that would be consuming potentially these protocols. I think the data is a lot in 2D, and my taking it back to my pedestrian signal example as a scenario, one of the things we encountered was the button that you actually press at a physical intersection. It's not always even at a standard height. Like it can be sometimes put near the knee. It can sometimes be put near the shoulder. And there was no data about that measured at all for the city. So when we were talking to them, it was first like, well, how do we measure that? And then what's the system that you would even store that in so that it could be used in like an AR application or VR application so that it could synthesize exactly like where that button was located. So just have that as a user scenario that I think if there was that standard and then there was software that you could type that into, I definitely encountered that as a barrier, which is trying to like brainstorm how to build a cool solution for people with disabilities in AR.
Yeah, no, I was thinking that's an interesting point, because I think that at least in the geospatial community, that's not like sound is something that's certainly not considered because it's just not something that people are familiar with working with. So I think broadening the what are conceptions of what has to be included within geospatial to make things work for everyone in an accessible way is certainly important for this community to consider. So no, that's a very interesting point. And maybe we can transition to a different question. We had one in the panel, or one in the Gitter chat, with asking what the best way to deal with geographic precision is when combining map data with augmented reality. Also, are there ways to anchor feature coordinates to the physical world? Maybe you can ask Patrick if he has any comments on that.
Yeah, so just in 3D, even before we get to AR, you know, precision has always been a challenge, right? In mapping, when you can do anything from kind of zooming all the way out and seeing all the satellites orbiting the globe to zooming into a car engine, right? And a lot of the 32-bit based GPUs will have precision errors with jittering or with Z-fighting. So, you know, a lot of the global scale engines will go to great lengths in order to emulate higher precision and do pre-computations for the coordinate system transforms. As for when you start bringing this into AR, the precision becomes super important just when you're overlaying that physical world. Like say it's an infrastructure or construction project and you want to put the HVAC in, but it's only just been framed out. And there's two components. I mean, one is getting, and for other folks on the panel I think to discuss, is getting the really accurate GeoPose position and orientation. And then the other is the rendering strategies to overlay it slash also Z-fight or depth test it with the physical world. So just maybe I can seed the conversation for others to pick up.
Yeah, I want to piggyback on that. I think the question of accuracy, Jan-Erik mentioned, he touched on it, that if we have a spatially mapped world that we can compare to the user's camera, what's sensing in real time, that will go a long way to combine the visual processing with the sensors like GPS and compass. So the combination of visual relocalization and using the native sensors is a key strategy going forward. There's no doubt about that. But then on the other hand, there's a lot of noise in the world, right? Big blocks of metal and water, bodies of water, terrible. And there's a lot of noise visually as well. If there are any mirrors or any reflective surfaces, they can reverse the readings. So we're not out of the woods, I think, from that perspective. The second part of that question was how to anchor the digital assets on the physical world. Really, at this time, there are just a few authoring environments that allow you to do that, and you can anchor to a floating object like a fiducial marker or an image or something that can move around, or you can anchor to a physical location that's been defined in the authoring environment. I think we're at a stage now where the innovation and the kinds of things that people are doing with augmented reality is a bit held back by just too few authoring tools. Everyone is using Unity, and it's a great tool if you're a game developer and you know how to use it already. And it's fantastic for prototyping and creating tests, but in the long run, for scaling, you can't have an app for every single object or every single orientation or place. So we're going to, I believe, see more diversity. We're certainly looking for that from the web community, from the 3D web community.
I'd like to follow that up with what's currently available, or at least being worked on in the web platform today to work on this. So with regarding geospatial, there is an early incubation in the Immersive Web Working Group called GeoAlignment. I've pasted the link into the Gitter chat. And here's a link to the README. So this is what the current status of this looks like. Getting feedback for this API would be very valuable. It's not being super actively developed at the moment. I think the last commit to it was made in August. But it's definitely something which we are are very interested in working on. With regards to the second part of your question, and anchor, like how do you anchor a 3D model to a space in AR? We actually have another API called Anchors, which I've put a link to. This one is a lot further developed and has implementations in the wild. And this is for anchoring. It lets you define an anchor based on a real world position, and then it will keep that anchor on top of that real world position so that you can place your 3D models inside the particular frame of that anchor to keep it in place. And that's where we're at today. That one is coming along pretty well, actually.
That sounds like a good starting point, because we, the extended view of GeoPose, we allow for connecting to different frames of reference. So obviously the GeoPose itself, the basic GeoPose as we define it, has a starting frame that is anchored to a geospatial frame of reference. But we want to allow for transforms between different local frames of references that can be nested within each other. And every AR rendering is a case of that, because they always use a Cartesian coordinate system for the rendering. And within that Cartesian coordinate system, you will have an anchor that you might want to add an object to. And there's a way to go from that anchor inside the Cartesian frame of reference and all the way back and expressing the real world position and orientation of that anchor as GeoPose afterwards. You can transform it into the other and the other way around. So both ways should be entirely possible to do within the larger conceptual framework of the GeoPose spec. Yeah, that was
great.
that was my comment on that.
Okay, thanks everyone for those great answers. And I guess I just wanted to pick up on something Christine mentioned because there was a related question related to like gaming, with a comment in the Gitter chat about that gaming platforms really have a full system design that really shines by enabling the integration between the gaming environment and interaction with their users, of course. Of course, accessibility is certainly an issue in some aspects of gaming, but there still is very good integration with users. So the question is related to how does current development on our side of the fence, so on the geospatial side and the website, align with the gaming industry, and I guess how we might be able to leverage their efforts to help in the work that we're interested in.
Yeah, can I jump back right in there before,
sure.
Even though I just spoke? There's a need for, we're in this early phase of this technology, there's a need for R&D. And Christine mentioned that we're at the point where we are relying on visual positioning to have accurate GeoPose. That is very brittle. Those cameras, they have low, typically on our devices, they have low dynamic range. And if the lighting conditions are poor, things can fall apart. We need to have like multimodal developments in the future. So I expect we have, multiple decades of R&D with different kinds of sensors that could work together to provide spike GeoPose in more robust ways, so that when the weather is bad or the lighting is bad or other conditions change, you could obtain your pose and continue to do real world spatial computing and display things correctly in challenging conditions. So the gaming environment, just like the AI world and just like the autonomous driving world, is utilizing game engine technology to simulate their systems. Basically, an autonomous vehicle, for instance, is you can look at it like a device with sensors, and all the major organizations who are working on developing that field, they simulate autonomous vehicle in a game engine to see how like synthetic sensor data can be handled by their autonomous driving systems. And they can tune the weather, the lighting, and the behavior of other vehicles and test those really edge cases. So the same thing applies to our the AR cloud technology area, that we should have similar tools to develop our field.
I'll chime in with
go ahead, Thomas.
Oh yeah, I was just going to say, like at least for staying on my audio theme for today, The Last of Us Part 2 is a game that kind of famously has been able to be completed by people who are blind, and it has tons of spatial information, and it uses kind of a novel sonar and kind of sound notifications to know where objects and things are. So I think from that standpoint of like looking at this professional game implementation and knowing that people have been like crying with delight about how well it worked, I definitely think the gaming industry is a good place for inspiration to being like, as you design like fully complete experiences, like validating with users, making sure that it actually does work end to end. So I reference that game as right now as kind of like one of the most accessible, exciting things, and it does do the 3D audio spatialization in innovative ways.
Cool. Yeah, I'd just like to add, so I really believe in order to advance AR for maps and to advance 3D geospatial in general, we really need this collaboration that's at the intersection of games and graphics and geospatial, right? Because if we're just coming at it from a geospatial or from a map world, I mean, when you go to 2D to then 3D, like 3D is not 2D plus 1, right? It's a whole new world. And then likewise, when you're a game engine and you want to add global scale, high precision, real world coordinates, and working with that massive data, you have to bring in a lot of the geospatial types of techniques. So one example is that at Cesium, we've been collaborating closely with Epic Games to build 3D geospatial right on top of Unreal Engine, right? Cesium for Unreal, where Unreal does the fundamental rendering and the lighting, which is incredibly amazing and sophisticated. And then on top of that, Cesium does the streaming for the 3D tiles. So based on the view, it brings in the the right real world content using the global precision. And I think we're really just at the beginning of this kind of fusion of gaming and geospatial.
Oh, that's very, very interesting. I just wanted to note for everyone that Christine unfortunately had to go to another meeting, so that's why she's dropped off the call. But if she listens to the recording, we'll just wanted to mention to say thank you to her for her presentation earlier and her participation in the panel. I think we have about 8 minutes left in the panel, so we have time to do a couple more questions. So one question that came up was, I guess we've been talking mostly about probably future states of AR. And also 3D components of that. So there's a question relating to how to get to that state and whether it would be beneficial, at least as a starting point along this path that we're going down for augmented reality, if the web platform supported 2D map rendering in HTML, which is what MapML proposal is aiming to do. So I guess if there are any comments on that, is whether that's at least a starting point for how to enable this new feature, that would be interesting.
Yeah, thumbs up from me. It's better to start with that, and then I hope we can build on that if we have a native map element that starts out as 2D. Then next thing is you extend it so you could have the globe maps and the immersive modes later on. So get on with it. That would be wonderful. Yeah.
If you want to be the change you wish to see in the world, building a custom web component is usually a great place to start. And that's
actually, yeah, I did one when I got my job in Nurkart at when I had my interview. I made a web component using one of the early libraries for creating web components, and it looks very much like the web components that is proposed, where you see the latitude and longitude as parameters, and when I moved around in the map, those parameters were updated. So yeah, I've been on that track. So but that was 2D maps.
It would be interesting if there was a native element. So currently in WebXR, which is the only way to do AR in the web, there's no way right now anyway to draw HTML elements into WebXR because it's purely WebGL based. So if there was to be some kind of native HTML element, the best way for it to be able to get into WebXR would be if it was able to expose some kind of buffer which could be loaded into the GPU to be used with WebGL or WebGL2 or WebGPU, so that that particular whatever engine you're using could then take that content and do smart stuff with it to lay it appropriately in your environment.
Great. No, thanks for your thoughts on that. Yeah, I think it'll be, I think as we move down this path for augmented reality, as it becomes a common part of everyday life, eventually we are going to be asking why the web platform doesn't support 3D and augmented reality natively. So it's probably an interesting idea to approach the 2D map component first, and then have something to build on for 3D components. And we have one other question from the audience, in consideration of Jan-Erik's earlier presentation, whether you think that the layer terminology is confusing in a 3 or 4D environment. Wondering if a term of view is better or if it has the same problem. So I guess a question about terminology. Maybe Jan-Erik, since this was your presentation, if you'd like to comment on that.
Yeah, people are routinely asking if the layer is appropriate. So for me, it's always been intuitive, but I understand that not everyone feels the same way. So I'm not sure about view, but there could be another word that sort of hits the nail on the head, and it might not be layer, but that is very coming from map world and also from Photoshop, Illustrator. Layers are, something that is sort of in the background as a concept that it's easy to fall back on, but some deep thinking could reveal a better concept.
I mean, Unity uses a layer concept too for laying out objects and setting that on there. So I think at least I've seen that terminology used there in that environment as well.
Okay, thanks. Okay, and I guess we're down to about 3 minutes left on the panel. So I think we'll ask one more question as kind of a closing question, but maybe everyone can address. So I guess I was interested in if there's one thing that you would like the attendees of the workshop to help with or consider for maps and 3D/augmented reality, what it would be. Since we have this audience here today who actually has the capability to do something, what you would ask of them. So maybe we can, if anyone has an opinion right away, feel free to jump in. We can have some time for everybody.
One thing which I'd really like is if people could take a look at some of the repos in the immersive web, and maybe even get involved if your company is a W3C member, and asked to get involved in the work we're doing in W3C, because it would be really great to have the input of people with maps as a use case, giving their opinion on, oh sorry, my camera just turned off, giving their input on whether or not the APIs we're designing will fit your use cases. And I think we definitely do not want to preclude augmented reality maps from working in the web.
Yeah, I mean, I'll just add that in 2D maps for my kind of world has already been like a constant challenge from when I got into this world of accessibility. So I just put out there to like really make sure people do care and consider the use case in 3D, because I mean, we still have a lot of challenges really considering just the 2D solutions for people with disabilities. And I'm very excited about what can come, but I'll just put it out there that I'm someone that's always interested in like trying out people's prototypes or things you're working on. So just definitely think of me as like someone that likes to try out samples and can like help you with the user scenario generation.
If I can chime in, I mentioned in my presentation that OpenAI Cloud is working on designing and implementing a reference open spatial computing platform. And what is more, we are actually trying that platform out in a city scale starting with 2 European cities. So there's the city of Bari in Italy and the city of Helsinki in Finland. And there might, maybe during this autumn, there might be a few more cities as well. And we are seeking people who wants to participate on experimenting it with what could be seen as an prototype open spatial web platform. It's consisting of standards and protocols. All the standards and protocols are sort of in flux, work in progress. Nothing is fixed, so it's a true like R&D kind of thing, but at a pretty grand scale. Bari, for instance, has 100 square kilometers that has been mapped so that you could obtain your GeoPose over there. So that would allow for kinds of use cases that span the city. So that is one aspect. Obviously, you can go to our GitHub, OpenAI Cloud GitHub repo and look at all the different projects there. Most of them are related to open spatial computing platforms. I encourage you to look into those. And also I encourage you to join OpenAI Clouds, participate in our working groups and our meetings on the open spatial computing platform. I think we're onto something very exciting. Feels a little bit like 1989, where Tim Berners-Lee were trying to invent the web with some standards and protocols and some implementations. And now we have this new opportunity for the spatial era. And this is not like a one-man show. This is something we're trying to bring a global community together to solve these challenges. Not only the technical, but also the ethical around privacy and security and user control.
Yeah, then just to kind of round things out, piggybacking on that global community comment, right? So I do believe that the AR hardware, is going to mature and become widely spread, right, for both personal and professional use cases. And as software folks, we should be building now, right? And we need a combination of platforms that will kind of enable everyone to build on top of and standards for the interoperability. So I would just put a very broad call to action for anything that you can do to contribute to open standards, whether it's W3C, Chronos, or OGC, anything from use cases to actual spec work implementation. It's really going to help lift up the whole community and bring AR forward as fast as we can.
Excellent, great. Thanks everyone for those last answers to the final question. So I'd just like to thank everyone for participating in the panel today. I thought it was really very interesting, especially for myself as a stereotypical geospatial user who doesn't really know anything about augmented reality or 3D. It was really illuminating to see the future that we're going towards. So thank you everyone for your excellent participation. So I guess the last portion of our session today is supposed to be a breakout session related to maps of objects, specifically GeoPose for web maps, which I believe is being led by Jan-Erik Vinje again. I just wanted to check with our program committee members because I believe we're a little over time today, so I don't know if there's any considerations around that, or if we can just move ahead with the breakout session.
I think we can just continue on in the same space. I think our captioner is dropping off, but beyond that, whoever is interested in the breakout, it'll just continue on in the Zoom conference system.
Okay, great. Thanks, Amelia. So I guess with that, we're free to continue. So Jan-Erik, you're free to go ahead.
Okay. Well, with that, being respective of people's time, we might try to not spend the entire 30 minutes. So maybe just open the floor to questions and suggestions, where you're able to facilitate that, so everyone who raises their hand can chime in. Is that so? A question
yeah,
to
that's fine. I think we have a fairly small group now, so if people want to ask their questions in the Gitter channel, that's fine. I'm happy to read them out. Or if people just want to to speak in the Zoom session, that should be fine. I think it will be okay.
Awesome. It's been a real challenge staying quiet for that long. Just kidding.
Well, feel free, you know.
Okay.
I'd love to.
So to get things started, we've got people coming from geospatial and thinking of data formats. You talked about GeoPose as a conceptual thing, but how do you actually integrate that in to like your GeoJSON or your other map data formats?
Yeah, so GeoJSON does sort of was an inspiration for GeoPose because it was so succinct and easy to comprehend. Just looking at it, it was compact. It wasn't a massive, overly complex XML structure. So it's been very popular in the web map community. I think we used it a lot in my workplace. We store map data sometimes directly as a GeoJSON. For instance, we had this where we were allowing users to draw features and save them and use them later. That was a good case for GeoJSON. GeoJSON, even though it supports 3D coordinates, is very much based in the GIS map data paradigm that has a lot of coordinates in for instance latitude, longitude. The pose itself, if you want to have a pose, it's hard to work in latitude, longitude. That is why the basic GeoPose sort of creates a local Cartesian coordinate system that is tangential to the ellipsoids at that position, the particular coordinates. So, well, sure, you might be able to add some attributes into a GeoJSON feature that could express the orientation of something at that point. So that could be sort of grafted directly on top of GeoJSON. But that's not a standard, and you might like add some sort of extra standard to GeoJSON that could support pose. The way we encode it's not published yet, but the way in our OGC standards working group for GeoPose, the way we encode it for basic GeoPose, the implementation target points towards an encoding format as JSON that is even more succinct than GeoJSON, but that can be that because it's more it's a simpler concept. It's not all kinds of lines and polygons and everything. You don't need to have a lot of structure to separate, but it's only a pose, and then you have a simpler object. Yeah. Does that answer some of the question?
Yes, thank you. Getting more ideas of what this would look like. If at the risk of dominating the conversation, another question is, are there devices that currently can record this information? Like if I'm taking a photograph, most phones can give me GPS coordinates of where I was standing, but can they give me the pose information that you can later reconstruct what direction I was looking at when I took that photograph?
Well, I'm not an expert on like EXIF data, but there's sort of metadata you can have associated with a picture. So maybe there's someone else who knows if you capture like geomagnetic sensor data and that kind of thing. I don't quite know if that is part of taking a picture on a smartphone today. Should be possible though. So yeah, no one here seems to know.
Anybody else played around with device sensors and figuring out what your camera is looking at?
So what you could do, you could, if you are in an AR context and you're speaking with a visual positioning service that has a very accurate position and orientation that it returns, there are a couple of service providers that provide just spatial position orientation already. Then you can sort of bundle the image together with that kind of extra metadata. If it's not supported directly in EXIF, you might be able to do that. So you take a picture and you're in an AR context, and you obtain a pose from when you took that picture. That should be entirely possible to annotate a picture with it.
Very slightly meta off topic, but I just want to note that EXIF is only one format, and I believe it's only supported in JPEG and a few other formats. There are lots of different metadata formats for raster data. There was an attempt a few years ago at W3C to unify them, but it didn't really go anywhere. There was a spec that was produced, but it didn't really go, it wasn't really adopted. I think that if we're going to, that is actually a fecund ground for standardization, is actually starting to look at how this metadata could be encoded in raster images if we wanted to do something like that. And that could also go into the annotation stuff that was talked about earlier. And there's a lot of, it's a fertile ground there. But there's still also some challenges.
The algorithms used by visual positioning always allows that you, if you have a good map of an area, you can always obtain that after the fact. So if you come back 3 days later, you have a photo and you know the general area and the local map, then you could run an algorithm and obtain your pose after the fact.
Mm.
That could be done for historical images, even though it's more challenging because more things might have changed. Vegetation and paints on walls and buildings that have been removed, all of that, but certainly possible to do with historical images as well. We see some AR apps that are doing that, where there's movies from standing camera somewhere, and they put that movie into an AR experience, and you can move to the right location, and you get some sort of window into the past, into the real world. It's quite a fun experience, it seems. Yes, I think I'm not gonna hold everyone here just to see if the questions and comments are sort of starting to dry up now.
Do you have any demos that you have something you can actually show us more than just the static images from the slides?
Well, you can Google to our partners. If you Google Immersal and Augmented City, you will be able to see some of the ways they can overlay stuff into the like city scale use cases. So that is definitely one thing you could do, and there will be more demos pretty soon from the test beds, where hopefully that is a demo of similar things, but then running on the platform, running on the preliminary GeoPose protocol, using the early version of the GeoPose encoding format, so that it's something that could scale in a different way than having a number of different service providers with idiosyncratic formats and protocols.
Okay, that's great. If you could put the actual names of those companies in the Gitter chat later so it's easier for people to find, that would be great.
Yeah, so just go to YouTube and you find those partners. Those are the two companies that are running the two first test beds. Immersal is running the one in Helsinki, and Augmented City is running the one in Bari.
I have a question. It's a little speculative, but since we have time, I may as well ask it. I had been thinking about maps, I'll be honest, as sort of 2D objects. And I recognized that there's an intersection with XR, but I hadn't really thought too deeply about it. But the more I think about it, I do wonder if it might not be a good idea to start with something more ambitious that enables a broader set of use cases. Including, not just traditional flat digital maps, but 3D with perhaps with GeoPose, perhaps with it seems to me like having GeoPose and XR is pretty relevant to an emerging web sort of that has AR and VR. And it seems like maps could be folded into that as a subset of that. Am I thinking about it wrong, or do other people feel like maybe maps by itself is actually only a subset of what we could do with AR, VR, GeoPose, 3D environments?
I'm sure you're right, but you got to start somewhere. Well, I shouldn't be jumping in on Jan-Erik's session, but you got to start somewhere. And 2D is like, I mean, I wouldn't call it simple because I'm not one of the geniuses inventing in the 3D world. And 2D already seems pretty hard to me, especially in the notion of making the content responsive to the container, like in 3D and like in reality, the container is the person, right? But in a 2D web map, the container is a rectangle on the screen, and it seems to me that they're connected, obviously nowadays with the mobile web and so on, but we haven't even got the browser rendering even basic 2D stuff in that rectangle for us yet. It's all done by web developers, right? Like, so I would like to see the plan for integrating this into a web that people can use, that school kids can learn. Because, I'm hearing a lot of high tech stuff here. And, where does that come back to? You know what I mean? Like, where does that hit HTML? So far as I can see, nowhere, except in a div.
Sure.
Those are actually, I would think both perspectives are very good points. So this is like a classical thing in software engineering. Like, you want to like do the redesign and refactoring, and you can try and like maybe just come up with, let's throw all the things we already did away and start from scratch, and that allows for some things to be easier. But then all the stuff you did with the old paradigm suddenly comes back, and like, oh, we usually do this and now we can't do that anymore. How can we bring that into it? So then you always end up with a long journey anyways, where you have to pull in stuff from the old paradigm into the new. but you have the opportunity to like have a gateway and say this is redundant now. We don't actually need it. This was totally meaningless to try and bring this into the future paradigm. That might be the advantage of doing it that way. But the big problem is that when you like throw everything away and start from scratch, it tends to take a long time before you have something that is remotely as usable as what you originally have. So
that's true, and also you lose the community of practitioners from the older tradition. That so there's a skill loss there. There's not a skill loss, but there's a people loss as people who are very knowledgeable about one area might not feel comfortable going into something that's too radically different. And also I'm just thinking about it from a pragmatic perspective. There are certain controls that you would expect to have in a map. Zoom, pan. There's the notion of tiling, which as far as I can see, is not really present in AR, VR, 3D worlds.
Oh, you would be wrong. Tiling.
There I am.
Yeah, tiling is very useful in the 3D world as well.
Well, then the pan and zoom seem also applicable. So maybe we should dig into the similarities between the worlds in order to make sure that even if we start with something simpler, though not simple, maps, that it is amenable to extension into 3D environments.
Yeah, Zoom actually interesting. I had just recently, just a few hours ago, I was demoing an AR prototype for someone, and one thing he asked out of the blue, I had no idea who to ask for that, but he was, could you zoom in this? And obviously, if you have originally a web map and it has zoom controls, and you can, if you then extend the original web maps to an immersive map and you still have a zoom control, what you would have to do is sort of take the same concept, but now instead of looking down at a map and zooming into the map, the sort of 2D map that you're looking down on, you're looking with your pose, and you will zoom along your pose, and it's a similar concept, but you could leverage the same control and have similar user interactions for it.
And having a native zoom pan mechanism in the browser, whether that's an API or however the interface goes, that would help with accessibility across different mediums.
Absolutely.
Because you could expose it as a standard control rather than just as a button or whatever.
Yeah.
With an API,
with an API, exactly. Yeah.
Yeah. Thanks. I appreciate you indulging me in that speculation.
Yeah. Okay. I think I don't think I should also soon leave this to have some dinner. Now we probably quite some time overtime. So thank you everyone for hanging around for this interesting discussion, and hope that people from this community touch and bump into each other for bringing spatial computing forward. Bye-bye.
Thank you very much, Jan-Erik.
Thanks, everyone.
Bye-bye.
Bye. Thanks for having me.
Bye. Thank you very much, Ada Rose.
Thank you, Ada Rose.
Yeah, I just wanted to thank everyone for participating today. And I guess just a reminder for everyone, so tomorrow we will be continuing the workshop. The sessions start at 12 o'clock Eastern time, which I believe is 1600 UTC. So we will pick up again tomorrow. So we'll see everyone again tomorrow. Thank you.
Thanks for moderating, Ryan.
Thanks a lot, Ryan.
Yeah, good job, everybody. Thank you.
Thanks. Bye.
Bye all.
Bye all.
Thanks, bye.
Boom, boom, boom.